So now that we've got our obstacles on the screen, there's actually a bunch of different things we can do, as you guys have started to think about. So today, what I'm going to do is I'm going to walk you through a bunch of different options. Okay, you don't have to do all of these, but I wanted to give you some ideas of things that would be possible. So here are some of the things that we're going to go through today. So these are some things we can do. So on a collision, either between two characters or between a character and an obstacle, we can remove or move something. So if we had an obstacle, we could remove that obstacle. If two characters collide, we could reset their positions. So we'll look at what that looks like. And we can also add and subtract points. So if we were to have a score when we hit an object or another character, we could add points or we could subtract points. So we'll look at what that looks like too. And then, so those are on collision. Those would be on a collision event. But then we can also do things every time you go through the event loop. So we could have obstacles move across the screen. This would be similar to Frogger or the ghosts in Pac-Man. And then we can also have a countdown timer. These would be things that would be independent of the player's movement. These would be computer moves. Some of them might even be close to an AI. Okay, so let's try some of these out. Okay, so now we're going to talk through a bunch of different options. So you don't have to do all of these in your game, but I wanted to give you some different ideas to start getting you thinking about what you can do, okay? So first, let's deal with our collisions. So we have two different collisions that we're catching here. Well, actually sort of three, but two different types. We're catching a collision between two different characters, right, between the two characters. And then we're catching a collision between the character and an obstacle. Then I said three because we're kind of doing two versions of that, right? One for character one and one for character two. So we can do different things when we get both of those collisions. Okay, so let's look in our code and see where that's happening. So right now, so I'm gonna go to my collision detection section. That is fun to say. So that is here, okay? So this first part is my collision detection between two characters. And then the second part is the collision detection between a character and an obstacle. Okay, so right now we just have print statements that are saying when it happens. This one is collision, prints no collision, and here we print that it had hit an obstacle, okay? So right now we're just printing, but that's a nice placeholder because it tells us where the code would go if we wanted to change that to actually do something. So let's make it do something. So the four different things we talked about were to move the character so they can be moved to a different spot on the screen, or it could disappear, and then we talked about doing score. So we can add to the score and we can remove to the score, or remove from the score. So we'll do the score first because that's really easy, right? So if we have a score variable, do I have a score variable? Let's see. Yeah, okay. So I have a score equals 10. So this would be for a game where we're counting up, right? So say every time you get we did before was like tag. So every time we collided with the character, we added one to the score. So that's pretty simple, right? So here where we're saying collision, we would just add score equals score plus 1. Done. Okay, and then we could do the same thing when we hit the obstacles, okay? So if you wanted to do something like in Pac-Man, where every time you hit one of the obstacles, you get a point, we could do the same thing. So character one hit an obstacle. So here we would want to do score equals score plus 1, okay? Now let's say we wanted to do something where it's more like Frogger, where if you hit an obstacle, you lose points. So then you can figure out how you want to do this. Maybe you would choose a certain number of lives or a certain total number of points. But either way, you probably don't want to start with 0, right? So I'm going to leave the score at 0. That's the one where we're counting up. And I'm going to add a second one that's lives. So I'm going to say there are 3 lives, okay? So then I'm going to come down here. So for my first character, we're going to say when they get the obstacle, they get a point. For the second character, I'm going to do the opposite, right? I'm going to decrement the lives. So I'm going to say lives equals lives minus 1, okay? Again, that's pretty straightforward. So both of these are pretty easy. Basically, whenever you have a collision, you either want to add or to remove from the variable that you're keeping track of the score or the lives or whatever you want to call it. All right, so now let's say when we collide, we want to move, okay? So I'm gonna say for this one, where the two characters are, if they collide, I'm gonna set them back to opposite ends of the screen, okay? So again, it's pretty easy. All we need to do is in the same spot, so this is the code that executes whenever a collision happens. So this is where we wanna do it. We would just set the X and Y for each of our characters to the point at the top and the bottom of the screen. So I'm gonna say, let's look up what we used for those characters. Oh, that's right here. Okay, so we used X1, Y1, and X2, Y2 for the center point of each of my characters, okay? So here I can say if they collide, I'm gonna set X1, let's say I'll set character 1 to the top left of the screen and character 2 to the bottom right. So I'm gonna have X1 and Y1 be the top left. So that'll always be 0, 0. So I can set it to 0, 0. I might find that what happens here is that the character is actually off the screen because this is the center point. So if I'm setting the center point to the very top left corner, it might only show half of my character. So I might have to move that. We'll check in a minute. But then let's set, and we'll do the same thing, and we might have the same problem with Y2 or X2 and Y2. So for those, let's set them, this is where it comes in handy to have our max X and max Y. So we'll set them to max X and max Y. So now I don't have to remember what my screen currently is because I know I've changed it a lot. It's okay, my program's gonna handle that for me. Okay, so let's run this. So now what should happen is when they collide, I'm gonna increment the score, but I don't know if I'm displaying the score anywhere. We'll see. If we are, it should go up. And then we're gonna set the two characters to the sides of the screen. So let's look at what that looks like. Okay, so I'm gonna have them collide. Oops. Okay, and do you see how they jumped? They jumped to the screen. So we are having that problem. See how it's like the center of their nose is at this point. So I know that my characters are 100 by 100. So half of that should be 50 by 50, right? So I can add 50 on either side to get them to show up. So I'm gonna go ahead and do that. Let's do that real quick because it's bothering me. All right, so here I'm gonna add 50, and I'm gonna add 50. And then here I'm gonna subtract 50, right? Because if I added 50, it would be even further off the screen. Instead, I wanna subtract so I can get it back. Okay, so now they should not be off the screen. All right, so let's do it again. So I'm gonna have them collide. Great. Okay, so now see their top left point of the character is in the top left point of the screen, okay? Oh, and the score went up, perfect, so that worked too. So now if they collide again, this score should go up to, here I'll try to get them both. It's hard to do both hands at the same time. Okay, great, so they reset back to the sides of the screen and now the score is 2. Okay, so one of my characters, remember we just set, I don't have anything showing the lives. I should probably add that in a second. But one of them, so which one is which? Oh, nice. Okay. So this gray one is the one where we said if it collides with an obstacle, it gets a point added to the score, okay? So see what happens is as I'm touching the obstacle, I'm still colliding, so my score is just going up and up and up and up and up. So what we probably want to do to fix that is we want to remove that obstacle. If you're getting a point for it, you probably want to remove it. And so that brings us to our final thing with the collisions, which is removing an obstacle or moving it. So we can talk about both. Let's look at both of those. So I'm going to go down here. Okay, so this is the point, character 1, which is my gray koala. He has a is getting a point every time he touches an obstacle. So what we want to do is when he hits that obstacle, we want to either move the obstacle or remove the obstacle, okay? So let's talk about the different ways that we can do that. So if we just want to move the obstacle, that actually is not as, or it's pretty straightforward. It's just basically the same thing that we just did with our characters. So all we want to do is we want to change the X and Y of the obstacle. So again, we would do that when it collided, right? So here, because of this if statement, we know that this is where we're checking to see the collision. This is where we find out that the collision happened. Then we print out the character hit an obstacle, we change the score right now, and then we're gonna move the obstacle. So to move that obstacle, all we want to do is change its x and or y, right? We just want to move it. So I'm going to just move the y since mine are all in a row. So I'm going to do O, which is my obstacle, right? Because I'm looping through. And so O represents the current obstacle that we're checking, okay? So that's how I can use O to represent that current obstacle. That's the one that just got collided with. And remember, if you do dot X, or we wanted to do Y, so dot Y, that will be its Y value. So that's saying this object O has a Y value. That's what I want. Go look it up, go find it. So then I'm gonna say that equals O plus Y, so whatever it already is, plus 50. Okay, so that should move it down every time we hit it. So let's try that. Okay, so I'm gonna hit it. Yeah, and then it jumped down. It actually jumped down twice because I remember my koala is 100, so it jumped down 50 and I was still touching it. So then it jumped down again. Okay, so now it's down here, so I'm gonna move my other koala out of the way. Okay, and then if I touch it again, see each time my score is going up and it's jumping down, okay? So I can chase it all the way across the screen. And then once it gets off the screen, I won't be able to get it anymore, okay? So let's talk about that. So here, this is where we're doing that change. You could also do an X. You could even do a random number. That might be interesting if once you hit it, it jumps to a random point in the screen. But what you want to do is you always want to check to see if it's off the screen, right? Because if it's off the screen, then you probably don't want to do it. Maybe you want to subtract or set it back to 0. So we could do something like that. We could say if O dot Y plus 50 is less than the max Y, is that saying if I add 50 to its current value, will it go off the screen? And if it will, or sorry, if it won't, right? So if it's less than off the screen, then we're gonna do that, right? What we were doing before, right? So we're gonna do O dot Y equals O dot Y plus 50. Okay, else, so this is what would happen if it was gonna go off the screen. So if the current Y plus 50 would be more than the max Y. And so then what we wanna do is, let's say we're gonna set it back to 50. So we'll say O dot Y, or we'll say, I don't wanna do 0 because then it'll be half off the screen. So maybe I'll do 20. Okay, so I'm gonna set, so this is when it would have gone off the screen. Basically what I'm doing is looping it back around. So this is what we did with our character, right? This is the same thing that we did with our character when we were looping him around the screen. Now we're just looping our obstacle. Okay, so let's see how that goes. Okay, so let me move my pink koala out of the way. And then we're gonna chase this obstacle down the screen. Okay. Okay, 4, 5, 6, 7, and now it jumps to the top, see? Okay, so that's one way you could move your obstacles whenever they're touched. Again, you don't have to, this is very obvious and it's very easy to follow it, but you could use a random number. You could alternate how you want, if you wanted to move like left or right, or you could even come up with some interesting AI algorithm here if you wanted. You can do whatever you want, but that's the basic idea. When the collision happens, you would change the X and the Y value of your obstacle, but you always want to make sure that you're checking to see if it's going off the screen. And if you don't want it to go off the screen, you should do something about that. Okay, so then our last thing we wanted to talk about with the obstacles and the collisions was removing an obstacle. So let's say Pac-Man style, you want to, when a collision happens, you remove that obstacle, okay? So I'm gonna do that with my other koala. So let's say, so right now it's decrementing lives, but we're not displaying lives anywhere, so it doesn't really matter right now. But let's say we want to, so now what we want to do is anytime there's a collision, we're going to remove that obstacle, okay? So again, here is where we know that a collision is happening, right? So this is our if statement that has our collision with character 2. So right now we're decrementing the lives, and we'll come back to that in a second, but then we want to remove the obstacle. So the easiest way to do this is just to take that obstacle out of your list. Because remember, the way that obstacles get on the screen is with this command right here, this loop that goes through the obstacle list and draws them all. So if that obstacle is no longer in the list, it's not going to get drawn, okay? So let's look at how we do that. So again, we know the current obstacle is represented by O. So we can say obstacle list dot remove. And remember, the remove function or method really for the list takes a value and we'll remove it from the list. Whoops. So we want to put here the thing we want to remove, the thing we want to remove, which is O. Okay, so what this is going to do, it's going to say go into my obstacle list and remove O, which is the current obstacle that we had the collision with. And so then when we do our loop down at the bottom that draws the obstacles, O, this one, whichever one this one was, will not be drawn. Okay, so let's look at that. All right, so I'm gonna get my gray koala out of the way, and we're now doing the pink koala. So I'm gonna try to just get one of these so we can see them disappear one at a time. So here, the first one, and then it's gone, see? All right, so now I get a second one, and now that one's gone, a third one, and it's gone, and a fourth one, and now it's gone. So now that we've got some ideas about what we can do with our collisions, let's talk about how we can move our obstacles. So in a game like Frogger or Pac-Man with the ghosts, right, they're moving. So those obstacles are constantly moving. So there's a couple of different ways that you can do this, but I'll talk you through one. All right, so I'm down at the bottom of my program where I'm drawing my obstacles, okay? So this is the code at the bottom where I draw my obstacles. So just like when we moved our obstacles when they collided, right, we can do something very similar down here. So the code would actually look almost the same. Basically, all we want to do is change the X or change the Y or change the X and Y by a certain amount, and then we want to draw it again. So the only difference here is that that was only happening when it was colliding. So that code was triggered by a collision event. This code, because it's just in the main event loop, will run every time the event loop runs. So that's something to keep in mind too, is that I'm going up to the top here. So remember the pygame.time.delay here, that's specifying how long it waits before going through this whole loop again, okay? So if you find your characters are moving too fast, there's two things you can do. You can play around with this, though be careful because that will also affect the amount of time it takes for you to press the keys. So you might not be able to move your character very fast. So if you change this value, you probably want to also check and see if your keys still work like you want them to. And then the other thing you can change is the speed of the character or how much it moves each time. Okay, so let's look at what that could look like. So I'm going to put it here. Ooh, I need that. Come back. So I'm going to put it in a separate loop here. But really you could combine these two loops. I was just thinking, should I do them together? But we're going to do them separately. And then you can combine them if you want. So for O in obstacle list, and then so now we're looping through each obstacle. So we can just change the X and the Y by a specific amount. So we could say O.X equals O.X plus 10, okay? But again, remember, you wanna, unless you want them to just go off the screen and never come back, you wanna check and make sure that they're looping. So we'll modify that to be, whoops, if O.X plus 10 is less than max X, then we're gonna add it. So if it's less, so if the current value plus the amount we wanna move it is less than the total screen, right? So if it's still on the screen, then that's good. We wanna just add that amount and do it. So O.X equals O.X, whoops, O.X plus 10. Okay, and then otherwise, we want to set the O.X back to the beginning of the screen. So that's looping it around. So we'll do O.X equals 0. Okay, so this is going to loop through each of my obstacles, change their X by 10, and then display them here. And so again, we could have made this we could make this just one loop. So here it changes the X value and then it draws it. So then we don't have to do 2 loops. It's a little bit better. Okay, so let's look at what this looks like. So our obstacles should be moving across the screen. Yeah, okay. So now they're moving. Oh, and then they jumped down because they disappeared because they collided with my koala. Here, let's run that again. They moved my koala down. Okay, so now if they don't collide with the koala, remember we made it so that they get removed when they collide. So if they don't collide with the koala, they'll just run across the screen forever, okay? So you might be wondering, what if I want my different obstacles to move at different speeds? So this is something that happens in Frogger. Some of the trucks go faster, some of them go slower. So what we can do there is, it's a little more complicated, but we can do it, okay? So what we can do is we can actually add in our, I'm going up to the top of my code to this obstacle class, okay? So we could add a speed variable into our class. So we can do, so we'll give it an X, a Y, a width, and a height, and now a speed. So then we'll have to add self.speed equals speed, okay? So now we also have to add, when we make our obstacles, we have to give them a speed, but now we can give them each a different speed. So I can give this one, we'll say a speed of 5, we'll give this one a speed of 10, we'll give this one a speed of 20, and this one a speed of 30. Okay, so they'll all be moving at different rates. Okay, so then the last thing we have to change is down here where we're updating it, at the very bottom, jumping all around the code. So here, where we're drawing, or where we're updating the X and then drawing it, right? So before we were adding 10 no matter what. Now we want to look at the individual character's speed to figure out how fast it should move. So instead of saying 10 here, or in both of these places where there's 10, I'm going to say O.speed, okay? So what this is doing is it's taking the current X, whoops, help if I could spell. It's taking the current X and it's adding the speed associated with that object. And then it's going to check that, instead of us checking the hard-coded 10, it's going to check its speed. So then each one can move slightly different. All right, so let's see how that looks. Oh, let me move down. Whoops. So see how they're all moving at different speeds across the screen? That's because each of them has their, and one of them was collided with my koala. I didn't move fast enough. But see, they're each moving at their own speed.